Inequalities, writing, graphing, and solving. The first thing we want to do is just review our inequality symbols. So do you remember less than and greater than? All right, less than points left, greater than points right? So I just keep in mind less than left. And of course, we have less than or equal to, greater than or equal to. So now I just want you to go ahead and try. Connect the underlying words with what symbol you think should go in the spot. There are a couple of tricky ones, so I really want you to come back and check your work. Pause. Is less than. So of course that's less than, points left. Is less than or equal to. Okay, we started you out easy. Is more than. Can't be 50 then, it has to be more than 50, so just greater than. Is at most 50. Here's a tricky one, at most 50. So can it be 51? No, because at most 50. So less than, but it could be equal to because at most. Is no more than 50. Is no more than 50. So once again, we have this less than or equal to. Because can it be 51 if it's no more than 50? Is greater than or equal to, okay, we're back to just being nice and easy. And the product of 7 and a number is at least 50. At least, this one can be tricky. At least 50. So it can be equal to 50, but it has to be greater than that. 50, 51, 50.5, any of those.
Okay, after that intro, let's look over here at number 2. Graph each inequality on the number line. Okay, so here we have A is x is greater than 6 because greater than points to the right. And then for B, we have x is less than or equal to 6 because less than points to the left. So if I want to graph this solution set, what I'm going to do is I already have these nice number lines sitting here for me. So I want to show that x is greater than 6 on this number line. So the first thing I do is I go, okay, 6 is right here. If x is greater than 6, can I be equal to 6? No. So the way we show that on a number line is we put a big giant open circle right there at 6 to show that, okay, yeah, we're sitting here, but we are not equal to that. So you can put that directly on the number line if you want. I'm a little bit sloppy, so I always put mine above to make sure that it's clean and clear. Whatever you do, you want the person looking at your solution to know what's going on. So if you want yours floating or on the 6, up to you. Okay, so now that I've shown, okay, well, x is greater than 6, all I've shown is that I'm at 6 here. If x is greater than 6, it could be 6.5, could be 7, could be 100, whatever. So that's going to be this direction. So I'm going to draw this ray pointed to the right to show that x is all of these possible values here shaded on my ray. Moving on to B, we have x is less than or equal to 6. Okay, well, we're at a 6 again, so 6 is right here. This time, since I'm less than or equal to, I can draw my circle shaded in. Again, making sure the circle is obvious, okay? So don't draw me a little dinky dot. You want an obvious circle sitting there to show, yes, I am equal to 6. And then if I'm less than or equal to 6, well, I could be 5, I could be negative 5, I could be negative 1,000, who knows? So that means I'm going to point here to the left. So as I draw this ray pointed to the left, that means that x is all these possible answers here and 6, okay, because I'm less than or equal to 6. Now, I want to also point out, notice my obvious arrows here at the end of my rays. X could be anything less than 6, so that means that this ray could keep on going all the way to negative 1,000,000 if it wanted to, so that's why we draw those arrows there. Let's see if we can use this to solve some inequalities.
Next, we want to solve inequalities. One thing that we do need to remember, though, is when you multiply or divide by a negative number, you must switch that inequality. So if it was a less than, you're going to switch it to greater than, and vice versa. And let's take a moment to write this down, because when we write things down, we remember them. All right, did you get that down? Once again, super important, not when you're dividing by a positive, not when you're subtracting, only when you multiply or divide by a negative number. Let's look at A really quick. 4 times the quantity x minus 7 greater than negative 20. So we could divide out that 4 right now, and that seems like a really good idea because it goes into that negative 20 nice and even. I get an integer answer there. But of course, it's the same thing if you chose to distribute the 4. Remember, 2 ways we'll get there. At this point, we have to use the addition property of equality, add the 7 to both sides, and we end up with x is greater than 2. And now to graph. When you're graphing your own, just make a quick number line. Make sure and put the 0 in place, 1, 2. We're going to expect that to be marked at a minimum. And then it's greater than but not equal. So of course we draw in a swimming pool to show that it's at 2 but not equal to 2. It could be 2.001, but it can't be 2. And then greater than, so I'm going to shade the number line greater than to the right and put an arrow on to indicate, of course, that it can go on forever. Now I want you to pause the video, try the next 3, and then just come back really quick and check your answers. I believe in you.
All right, let's see how you did. The first one I'll go over a little bit closely, and then the next two I'll go through faster. So as the first one, the first thing I'm gonna do is distribute, because I have those parentheses there, so I'm gonna have negative 6x minus 10. I'm gonna combine like terms, negative 6x minus 14. It's greater than or equal to negative 2. Add the 14. Okay, here's the crucial step. This is where you can either make a really big mistake or be totally on the right track. As I divide by this negative 6 here, I should have an alarm going off in my head. I just divided by a negative, and look at, Ms. Peart wrote about this. Anytime we divide or multiply by a negative in an inequality, we have to flip that sign. So I'm going to write x is less than or equal to, instead of greater than or equal to now, negative 2. Do not forget to flip that inequality. So now the number line, I'm gonna make sure I have 0, get my negative 2 on there. It's less than or equal to. Less than, left, done. All right, so let's look through C. The first thing I did was distribute, and then I subtracted my 3x, and something weird happened. Oh my gosh, I got 9 is greater than or equal to 6, and there were no more x's involved. Is that true? Is 9 greater than or equal to 6? Well, greater than or equal to, only one has to be true. 9 is greater than 6. Yeah, it's not equal to, but it's greater than. So this is actually a true statement, and it's always true. 9's always greater than 6. So what do we do when something's always true like that? Since 9 is always greater than 6, that means no matter what number I plug in for x, everything's going to work. So x is all real numbers, so there are infinitely many solutions for this one. Well, what's that gonna look like on a number line? If x is all possible real numbers, there's infinitely many solutions I could graph. So I'm gonna still label 0, but when I go to draw my ray, now it's gonna be like just this big line where I'm gonna shade the entire number line to show that every possible value would work for this inequality. Okay, as we look over at D, the first thing I did was combine like terms on that left side and then, get my x's to one side, and that's where, yet again, something weird happens. I end up with 4 is less than 4. Is that true? Is 4 less than 4? No. So this isn't a true statement, so this is almost like our no solution situation with equations. So I'm gonna say, like x, there isn't a possible x I can plug in and satisfy this inequality, so I'm just gonna say no solution, which means I don't actually have a solution to graph on my number line.
Going to look at a word problem and write an inequality and then solve it. So let's take a quick moment to read it. The width of a dog's exercise crate is 5 feet less than the length. Okay, so we have a rectangle, we have the length, we have the width, and it says the width is, right, the width is 5 feet less than the length. So remember when we learned 5 feet less than, that means that it goes at the end. So the width is actually L minus 5. The width is 5 feet less than the length. The perimeter is no more than 16 feet. So the perimeter is no more. It can be 16, but it can't be any more. So less than or equal to 16. All right, then let's go ahead and write our expression for perimeter, which is add all sides, or 2 widths and 2 lengths. So 2 lengths plus 2 widths, but remember my width is being represented by 5 less than the length, so L minus 5 is less than or equal to 16. As you can see, we went ahead and distributed the 2 into the L and the negative 5, and then combined like terms. Now we're going to add the 10, divide out the 4, and we get L is less than or equal to 13/2, or 6.5 feet. So any value for L that is 6.5 or smaller will work for both of them. Next, let's talk about compound inequalities. So this is when we have more than one thing going on in the same problem. So a few things for you to think about before we even tackle some of these. We need to remember and shades in, and go ahead and highlight that or circle that, and or shades out. You'll know what I mean in a moment. And the other thing we want to remember is that we never write an or statement as a linked inequality. That's one thing that you'll also see below when we start solving these.
Okay, so let's solve a compound inequality then. So compound inequality just means it has the word and or between it. What we can do is we can just solve them separately, and then we're gonna graph them and see how that looks different on our graph. So for the first one, I wanna solve for A, so I'm gonna divide off the 2. A is gonna be less than 2 because 4 divided by 2 is 2, so that's it's part of my solution. So then for the next one, just solving really quickly, negative 3a is less than 3. This is where alarms should be going off, because right here, when I divide by negative 3, what should we be thinking? I hope that you're saying flip that inequality. I'm going to flip this inequality sign. So it was less than, but now I'm going to make sure I write it as greater than. Be so careful. Be on the lookout for that. It's only because I was dividing by a negative number. So A is greater than -1. So far I've got this kind of solution. A is less than 2, and at the same time, A is greater than -1. So when I go to graph this, I'm gonna do something a little bit different. I'm gonna put my 0 on there just like we did on the front, but I'm gonna grab a pencil really quick just because it's our first time graphing a compound inequality, so I'm gonna be careful. So I'm gonna just graph one at a time, really nice and light in a pencil because I'm going to erase some stuff in a second. So A is less than 2. So 2 would be right about here. A is less than, so that's an open circle. Less than 2 is going to go this direction. I'm just going to draw it real light, pointed that direction. You can draw it, point it out if you want, okay? A is greater than -1. -1 would be right here. A is greater than it, so again, open circle, and it would be pointed this direction right here. This looks so funky. We haven't had something look like this yet, but this is what Mrs. Peart was talking about before when she said and shades in. And statements mean that my solution needs to satisfy both of the inequalities. My solution set needs to satisfy both of the inequalities here. I need to be less than 2 and I need to be greater than -1. So my solution's actually the overlapping area here. So when I draw my actual answer or my solution set on my number line, I'm gonna draw it like a bar, kind of like a dumbbell, from -1 to 2. Anything else that was extra pointed off does not satisfy both of the inequalities that were part of my solution. So I cannot include all this stuff that's less than -1 or all this stuff that's greater than 2 because that violates one of these two things here. So this is my solution graphed. So now I want to come up with a really nice way to state my solution algebraically. Well, you can kind of see X is all these possible numbers in between here. I'm gonna write that word down. So when I write my answer, I almost wanna make it look like X is between two things. So if X is in between -1 and 2, I'm gonna complete that with inequality symbols. So over here, oh no, it was an A. So let me fix that. A, and A is in between. So if A is less than 2, I'm just gonna copy that inequality symbol right there. If A is greater than -1, well, right here, -1 comes first. So if A is greater than, I'm gonna make sure that my inequality symbol still opens to the A. So I'm just flipping that inequality symbol because I flipped the order from the original solution set.
Looking at B, now that we kind of know how to write an and statement as a linked inequality, when I look at B, I already know that it's an and statement. The nice thing about writing it this way is then when I go to solve it, I can just do it all at one time. There's 3 sections. So when I add 2, because I have to undo that first, add it to all 3 sections. And then the same idea when you divide the 5, divide all 3 sections. Now we're going to go ahead and graph. So I'm going to put the 0, I'm going to put the 1. Oh my gosh, what about 9/5? Well, 1 4/5, it's a little less than 2. So I'll go ahead and put a 2, and then I'm going to kind of put a little mark and say 9/5 so I know which one I'm talking about. Now the other thing, did you notice my mistake? It's 1 less than X, less than or equal to. I forgot to bring that equals to down. So slow down and check your work because we all do that sometimes. The equals to, I want to put a big dark circle, but the 1, I make it like a swimming pool. It cannot equal 1. And then let's make it like a dumbbell. It's shaded in and shades in between.
Okay, moving on to C. C is going to be our first or compound inequality. We don't do any of the algebraic work differently. It's just going to affect the way our solution set looks in our final answer. So let's start solving these just like we were solving the other ones. So take a moment. I'll solve the first one separately than the second one. Then I'm going to divide by this -2 to get m by itself. And I hope you have that alarm going off in your head like I do in mine. What do I have to do when I divide by that negative sign? I got to flip my inequality sign. So first part of our compound solution here is m is less than -8. Then as I go solve this next one, I get 4m is greater than or equal to -20. Okay, and then I'm going to divide by this 4 here. Okay, I'm going to get -5. When I divide by this 4, do I need to flip that inequality sign? Because I have this negative number on the other side? No, I don't need to flip the inequality sign. It's only when I am multiplying or dividing by a negative, not if just my solution has a negative number in it. So I'm going to say, okay, m is still greater than or equal to on that one, -5. Let's see how this graphs. So let me get my 0 on here. M is less than -8 is going to be the first one I graph. So -8 would be like way over here if my 0 is going to be in the center. Less than is going to be an open circle. Make sure it's obviously open. And then less than, so that could be -9, -10. So I'm going to point it to the left. Okay, then M is greater than or equal to -5. Well, -5 would fall right about there. And then greater than or equal to, close circle, make sure it's nice and obvious. Greater than or equal to, well, 0 is greater than or equal to -5, so I'm gonna make sure I point it in the 0 direction. So notice how this looks different than an and solution because I don't have that bar like the and statements where it kind of look like a dumbbell. Instead, I have these little arrows that kind of point the opposite direction. So it's almost like I'm showing off my muscles, right? So or statements showing off, and statements look like that dumbbell. So if this is my graph solution set, I want to make sure I say my answer algebraically correctly. Since my answer isn't trapped in between, if there's no natural way to trap my variable in between these two things, we're not going to try to write our solution as a linked inequality. Instead, we're going to say m is less than -8, or we're physically going to write the word or, m is greater than or equal to -5. That would be my official algebraic solution. What's kind of cool about or compound inequalities is to be a solution, I only have to satisfy one of these. So if I say, oh, could m be -9? Well, since -9 is less than -8, yes, it could be.
Okay, D, go ahead and pause it, do it, and then I'll come back and I'll check the work with you and see if you need help graphing. So this is interesting. We get m is less than or equal to 7, or m is greater than or equal to 7. So when we go to graph that, we of course put our 0, we put 7, and then it's supposed to equal, so I'm going to totally shade in 7, but the first one says less than or equal to, and the second one says greater than or equal to 7. So in this case, our solution set is all real numbers because every single thing on that number line is shaded. So all real numbers. Do you remember the double bar R for all real numbers? If we wanted to be very specific, we could say m is a real number.